right, any feedback, any comments as to this first week, the first week of homework and what happened? We went okay? No questions from the homework?
Thank you for the tutorial.
Okay, so if I ask any question from chapters 1 and 2, you guys will get 100% on those questions on the quiz. Yeah. Is that correct? Yes, we have a question here. All right, go ahead.
I think it was 2.5.
Okay. So normally I don't go through do a review of all the exercises in class, but I'll do one quickly right now. It says it shows the histogram of televisions, and was there a specific part that gave? All right. It says according to the histogram, about how many homes do not have a television. You're going to answer how many homes are represented in the bar that has 0 television, and it appears like 1. How many televisions are in the home that has the most TVs? Okay, and there's one home that appears to have 9 TVs. Well, okay, I think I answered all of these questions in the tutorial video also, so. Do you have a specific question?
Yeah.
Okay. All right. Give you a. Also, I did have office hours. I came here at 6 o'clock, and I just waited. So if you come early to class and you have questions or things like that, that serves as your office hours. So don't hesitate to approach me at the table with your questions.
I think my question was just like, as far as reading the graph, the way it was like drawn out. I think that's what kind of confused me.
Okay. So
Like where it starts from 0 and then it goes to 1. So since the number of TVs at 0 and there's a bar, the 0, I was just confused as far as the numbering goes. I didn't read it well. But then after I saw your tutorial, I kind of got it.
okay, so the point of exercise 2.5 was so you understand how to read a histogram, because this is going to be a very important skill. So you see a bar at the number 0. What does that mean? The bar, how tall is the bar at 0?
1.
It's 1 unit high. So what does that mean?
That there's 0 people. Wait, no, there's. That's what confuses me.
Okay. What is the underlying data? Okay, the variable is the number of TVs. All right. Could a house have 0 TVs?
Yeah.
Yes. Okay. So, how many houses have 0 TVs?
1. So 1 house.
1. That's what happens. Okay. How many houses had 2 TVs? Looking at that bar. Histogram. It looks like around 13 or 14 houses had 2 TVs. Okay. So that's how we read a histogram. Exercise 2.5 is a good one to practice, just to make sure you do understand how to read a histogram. That is a critical skill. If you end this class and you're unable to read a histogram, again, you don't deserve to pass. So make sure you know how to read a histogram. That's very important. All right, well, we'll continue on. We're going to finish out chapter 2, which is just kind of summarizing and displaying categorical data. And we'll spend a little bit of time going over this, and then we will move on into chapter 3, where we cover summaries for numeric data. And you do have a quiz next week. We'll talk a little bit more about the quiz later on, but the quiz will cover chapters 1 through 3. So everything that I cover here today is fair game for the quiz next week. this is finishing out chapter 2. And we are going to talk about some categorical data. Okay, so we can display categorical data with a bar chart. So let's say we went to an elementary school. We picked a classroom and we just asked what is the, and we classified each student based on their race or ethnicity. Okay, so ethnicity or race could serve as a categorical variable, or it is a categorical variable, and depending on how the class looks, we would have a student, and we would write race, and let's say we have Adam. Adam maybe is white, and we have Becky, and maybe she is Asian, and then we have maybe more students. Maybe we have Black, Hispanic, or Latino, maybe mixed race, maybe other. Okay. So in this case, this would be quite a diverse classroom, just in the first 6 or 7 students that I pulled, but maybe these are possible races that we have. But we could go to, let's say, depending on the neighborhood or which community we go visit, the students may not display as much diversity. So if we were to go to an elementary school, and we list out all of the students, perhaps all of them, maybe a great majority are Hispanic, Latino. So, student 1, if we just label these student 1, student 2, student 3, student 4, maybe we have class that looks like this, maybe a white student, another Hispanic or Latino student. So this, that's one possibility for a classroom. Okay? And we could imagine, a classroom maybe of 25 students, 30 students, and the listing of students looks like that. Whereas if we visit another classroom, we list out the students. Maybe we have white, Hispanic, or Latino, Black, white, Hispanic, Asian. Okay. All right. So this would be the underlying data. This would be classroom 1, classroom 2. And we can summarize this or display this with a bar chart. Okay. And in order to do that, we would first need to create a summary table. So I'm going to create a summary table for classroom 1. This is sometimes called a frequency table. And so here I only have 6 students represented in classroom 1. And so my frequency table, I would list off the race. And so far, how many different races are represented in classroom 1?
2.
2. We have Hispanic or Latino students, and then we also have white students. How many Hispanic or Latino students do we have? In classroom 1? We have 5. And how many white students do we have? 1. Okay, so this would be my frequency table for classroom 1. Is that okay? All right, go ahead and make a frequency table for classroom 2. Okay, so how many different races or categories are represented?
3.
Okay, so I have white, I have Hispanic, I have black, and Asian. All right. How many white students are represented in classroom 2? 3. How many Hispanic students? 2. How many black students? 1. And how many Asian students? 1. Okay. And if you have a different order of the races or ethnicities, that does not matter. Okay. Again, with a categorical variable, there is no determined order. There's no, if you want to put these in alphabetical order, that would be allowed. If you want to put them in reverse alphabetical order, that's also allowed. If you want to put it in any order that of your choosing, also allowed with a categorical variable. Okay, so we are going to now represent what we see in the frequency table with a bar chart. So the bar chart, you would write across the bottom the different categories that you have listed in your frequency table. So here, I'm going to do one for classroom 1. So one of the categories that we have listed is Hispanic, and the other one is white. And the vertical axis will represent a count. So at the bottom, I'm going to put in 0, and I'll put 1, 3, 4, 5. So in classroom 1, I had 5 students who could be categorized or labeled as Hispanic or Latino. And so we have a bar that's 5 units high. And we had one student who would be considered white. And this is my bar chart for classroom 1. Does that look okay? We do the same thing over here. a bar chart for classroom 2. Yes, question?
What happened? What if so it wouldn't matter if you attach them together? You get what I'm saying?
Oh, if the bars are touching
Yeah.
each other?
It's fine.
Stylistically, we have a tradition of putting a gap between the columns for a bar chart. In a histogram, we have the bars touching each other. For a bar chart, tradition has us put spaces between the bars. Is it incorrect to have the bars touch? It's not wrong. It's just, I guess it feels a little funny. Okay. Yes.
Also, you said that there's no, with the bar chart, there's also no sort of order you can do in the
Right. So the order of the bars here is arbitrary. Maybe it's in order from the race that has the most people represented to the race with the fewest, so from greatest to least. But if we were to rearrange the bars, that would be fine and not a problem. Okay. So, could go, also, okay, the order of the bars, however you want to do it. It's fine. Okay. Are there questions on the bar chart? All right. So here's a simple question, but maybe it's not simple. Which classroom, which bar chart indicates greater variation or greater variation in the data? Classroom 2. Okay. Classroom 2 shows us there's more ethnic diversity. Okay. Or when it's categorical data, that would just be variation in the data. So this one has more variation. And this one has less variation. Does that work for you guys? So that's one thing to keep in mind when you see a bar chart such as this that exhibits more variation, because the underlying data, if you were a guest at this school and you entered classroom 1 and you entered classroom 2, which classroom would you say is more diverse? You would say classroom 2. Okay, and that's essentially what we are saying when we're talking about variation in categorical data. If there's one category that seems to dominate the other categories, meaning nearly all the students or all the people are assigned to one category, that means you do not have very much variation. Okay, you have very little variation if nearly everyone is in the same category. If all the different categories are equally represented, then you have lots of variation in the data. Yes? Question?
So say that it was like further diverse when it's one across the board and then one of the races has a class, that would be less variation, or would that be considered more variation?
Okay, so I'm going to make sure I understand your question. So we're asking, so if we have something like this versus this, or I don't know.
Right, let's suppose, I mean.
Okay, so all right, between these two bar charts, which bar chart has more variation?
My question is,
The lower one. Okay, this one has more variation. This one has less variation. I don't know.
well, really, it's just, I was trying to figure out, so if one of the categories just happen to have more of like a amount, then that would be considered a less variation.
So the terms more or less imply that there's some kind of comparison. Okay? So if you are looking at one bar chart all by itself and you have nothing against to compare, it's difficult to say, does this have more or less variation? This bar chart had less variation than what I just erased, but if there was another bar chart that was like this one has more variation than this. Okay, so it's difficult to answer, does that have more or less without having something against which to compare. All right, is that okay? Yes, question.
Is the comparison always going to be that easy to see?
If I were to ask you a comparison question, it would be that easy to see. Or the comparison should be quite easy to do. You have, I think, one or two homework problems that ask you to compare variations in bar charts, and it should be easy. Yes?
And what was the difference between bar chart and histogram?
So a histogram, what kind of data are we using for histogram? So last week we covered histograms, and it's for numeric data. Exactly. Okay. And what kind of data are we dealing with when we're making bar charts? Categorical. So that is the number one difference. Okay. Histograms, numeric data. Bar charts are for categorical data. And the second difference, which is more stylistic, is that histograms do not have gaps between the bars, whereas bar charts do. That one is less critical, but that's kind of what we do.
You said that variation, the term variation is directly towards categorical data.
No, variation exists for all data,
Oh.
okay, whether it's categorical or numeric data. All right? When we're talking about variation in categorical data, we are referring to the idea of, is everybody in one category or is everybody in different categories? Okay. We're going to talk about variation in numeric data
And many.
in just a couple moments here.
If you were to ask us to define, for example, the symmetry of a graph that we just showed.
Okay, so symmetry is a term that is reserved for describing numeric data. Okay? There's no symmetry for categorical data or bar charts per se. Because with a bar chart, one of the things about the bar charts is that the categories can be rearranged. So in one arrangement, maybe I can make something look symmetric, but there's no actual symmetry there because I can rearrange the bars. So symmetry is something that refers to the histograms and numeric data. Okay? So it's very important that we keep track, or we distinguish what applies to numeric data and what applies to categorical data. This is partly why I've separated last week's stuff from this week's stuff, although in a moment here we will go back into numeric data. But the ideas of symmetry, you know, how many modes we have, that's all numeric data. Okay?
Yeah. So their focus is just categorical.
No, just what we did right now is categorical. Okay? That wraps up chapter 2. You have homework in chapter 2 to kind of test out these concepts, make sure you understand them. And please make sure that you do. And if we're feeling okay with that, we're going to move on to chapter 3.
And you probably answered that, I just don't know.
Okay, let's
Um,
just ask away.
So, as far as the past chapters for histograms, numeric data, the symmetry, the spread, and all of that is not anything to do with bar.
Right, so these concepts covered last week apply to histograms and numeric data. So the concepts covered last week were concepts such as the center, the spread, the shape, being skewed or unimodal, that type of stuff. That applies to numeric data. As you read the book this week in categorical data, there is one word that will appear, and that's the mode, and that just means the bar that has the most number of people in it. Okay, so the tallest bar is considered the mode, but keep that separate from unimodal and bimodal and all of that. Okay, I know that they're similar sounding, they're based off of similar ideas, but keep the categorical stuff separate from the numeric stuff, please. Is that okay? Good. So we are going to, that will wrap up chapter 2. You have homework on chapter 2. And now we will move forward into so if you need to, in your notes, put a big bar or horizontal line to indicate that we are now in a new chapter, a different topic, because now we are entering chapter 3. And everything in chapter 3 applies to numeric data. I make a big deal about this numeric data, categorical data stuff, because your analysis, all of the things you do, are going to be very different for numeric data versus categorical data. However, in the same data set, you might have both numeric variables and categorical variables. So it's very important that we can distinguish one from the other. All right, so numeric data, again, tells us how much, how many. These are the variables that are generally recorded in some kind of number. And last week, we said when you are describing a numeric distribution, there are things that you want to talk about. Okay, and I just mentioned them like a minute ago, but let's make sure we understand. What are the things that we want to talk about when we are describing a numeric distribution? Just write this. Describing a numeric distribution. Or in other words, when we're describing the data of a numeric variable, we should mention do you remember the things that we should mention? Okay, one was not a histogram. A histogram is a way to visualize a numeric distribution, but when describing these things with words.
Spread.
So, okay, so one of them is the center of the distribution. We want to talk about the center.
Right skewed.
Okay, so yeah, we want to talk about the shape. And the shape consists of two parts. One is the symmetry, whether it's symmetric, skewed, okay, and then the other part, once we've covered the symmetry,
Spread.
not when we're talking about the shape, okay? Spread is something we want to talk about, but that doesn't go under the shape. We want to talk about, so when we're talking about shape, we want to talk about the symmetry, whether it's symmetric or skewed, right skewed, left skewed. And then the other part is, yeah, how many peaks, the number of peaks. Okay, make sure, if I ask you to describe the shape of a distribution, make sure you mention both of these things, okay? If you only mention one and not the other, you will not get full credit, all right? When I say describe the shape of a distribution, you have to mention both the number of peaks and the symmetry. So tell me, is it unimodal, bimodal, multimodal? Is it symmetric, skewed, skewed right, skewed left? Another one that doesn't quite fit would be uniform. But so these are the things we want to talk about: the center, the shape, and the spread. Okay. So we've already covered symmetry and the number of peaks last week, and we talked about the ideas of center and the idea of spread. Okay, and we said, you know, the center is kind of like this, and the spread is kind of like this. Well, we can be more specific with the ideas of center and spread by applying some kind of number. Okay, we have a summary number. We have a number to summarize the center. We have a number to summarize the spread. Right? And we'll have names for these: the mean and the median and all of this. But just keep in mind that these are numeric summaries. These are ways to these are ways to summarize what aspects of the distribution. Okay. But it's important to also keep in mind that these are just summaries. They do not give us the entire picture. If somebody just tells you the mean, or gives you one of the summary numbers for center, it gives you an idea of what the data might look like, but it doesn't give you the entire picture. Okay? For example, and we do things like this in our day-to-day lives all the time, and we're very aware of the limitations that these things apply. So, if let's say you don't know anybody, or not don't know anybody, but let's say there's a particular person you don't know, except you hear one element of their life, and you just say, "Oh, my friend so-and-so earns $250,000 a year." Okay, already that gives you an idea of this person's life. You have no idea who this person is, what he or she does, things about that, but you hear this number, $250,000 a year, and it's already given you a picture in your mind of what this person might be like. Okay? And there's already some assumptions you can make about this person that you wouldn't make for someone if you said, this person makes $25,000 per year, or things like that. Okay, so when you hear a single number, it gives you an idea, but it doesn't tell you everything. Okay? But it does give you some information. Or in the same way, do we have any fans of football in here? Okay. So they have at the end of a game, they will give the quarterback a passing rating. Okay. There's a single number that they apply to the performance of the quarterback, and it includes things like how many interceptions and sacks. Negative things count against it. Positive things like completed passes and how many yards, this and that. They're all summarized in there. They're all kind of calculated in some formula down to a single number. So if you hear a high number, it means that quarterback had a good performance. If you hear a low number, it tells you the quarterback did not have a good performance. But again, it doesn't tell you the full picture. It's just summarizing an entire game or entire season or whatever it is down to a single number. Okay? And that's all that these things do. Okay? They summarize things down to a single number. And single numbers in of themselves don't have much meaning. But if we have a summary number for one set of data, and we have a summary number for another set of data, by being able to compare those summary numbers, we can get an idea of comparing the sets of data. Is that concept okay? This is why we bother even with coming up with summary numbers, is so that we can basically boil down a set of data to just a few numbers, and we can compare these few numbers with these few numbers. It would be very difficult to look at all the individual pieces of data of one data set and compare them to all the individual pieces of data to another data set. We could do that, but it would be difficult by just kind of compressing a set of data down to a few numbers, we can compare these few numbers to these few numbers. Okay, and so the summary numbers we're going to learn today are the numbers for center and the numbers for spread. Depending on the shape, when we're talking about the symmetry, might give us an idea of what summary numbers we might prefer to use. Okay, so if our numeric data has a symmetric shape, we might prefer to use the mean and the standard deviation. That's our summary numbers. If our data is skewed, we might prefer to use median and quartiles. Median, quartiles, range, and IQR as our summary numbers. That said, all of the summary numbers that I teach you today can be applied to any numeric data. These are just maybe what we would prefer. We often call these summary statistics, okay? Also, and again, I will just reiterate what I said earlier, is that summary statistics attempts to boil down a data set to just a few numbers. That we can then use okay?
What does it say, summary statistic attempt to what?
Attempt to boil down. So that would be an idiom for how would you describe boil down to?
Come down to,
What's that?
like it comes down to.
Yeah. I realize that we have some international students here, and so phrases such as boiled down might not make sense. It's kind of the idea of reducing a complicated thing to just something simple, or removing the unnecessary parts, just the essentials. Yeah. All right, I will avoid idioms.
What do you mean by skewed if the data is skewed?
If the data is skewed, okay. Do you remember last week's lecture? And we talked about the shape. Okay. So what were the kinds of shapes that we could see?
Like right, left, symmetric.
Okay, so we had right skewed and left skewed,
Oh,
and we had symmetric data. So what did it mean for data to be right skewed? Do you remember any, or can you think of any examples of numeric data that might be right skewed? So I'm asking.
a left skew would be an exact, like test, the overall average of test grades on the exam.
Okay, so not the overall average of test grades, but the individual test grades might be left skewed. And what did it mean to be left skewed?
I forgot like the exact definition.
Okay, I'm not looking for an exact definition, but just kind of the general concept.
That they were higher.
Okay, so the idea behind left skewed is, remember, a distribution of data, we have many different individual people and a number for each person. So if 100 people took the test, we would have 100 numbers included in this data set. And some people's test scores will be higher, some people's test scores would be lower. In a left skewed data set, which I believe test scores would be left skewed, what we have going on there is that most people score in a certain range. Score maybe 80, 90%, something around there. We don't have many people scoring very much higher than 90%. You're probably not going to have anyone scoring over 100%, depending on how this test is written. On the other hand, are there going to be some students who score as poorly as 20% or 30%? Yeah, not very many, but there will be students with poor scores. And so, because it is possible to score much lower than everyone else, but impossible to score much higher, you would have a left skewed distribution. So that would look something like this. Most people would score between 80 to 90%, and a few people would score down in 20%. On the other hand, a symmetric distribution would be something like this, and this would apply for, I would say, people's heights. If we talk about men in the United States, most men are around between the heights of 5'8" and 6 feet tall. Okay? Do you have men who are taller than 6 feet? Yes. Do you have men who are much taller than 6 feet, like 6'6"? Sure, not very many. Okay? But if you go in the opposite direction, down to 5'2", do you have some men who are as short as 5'2"? Yes, not very many. Okay? So in this case, you have people who are much taller, but not very many, and people who are much shorter, but not very many. And therefore, you have something that looks symmetric.
When you were saying that all of the summary numbers can be calculated for all numeric data, were you talking about like as far as the median, quartile?
Yeah, so the numbers that I've said, the summary numbers that I've mentioned, and I will list all of these out, but I mentioned the mean, I mentioned the standard deviation, I mentioned the median, the quartiles, the IQR, and the range. These are all different summary numbers or summary statistics. They can all technically be calculated for any numeric set of data. So any data that's numeric, you can calculate the mean. Whether it's skewed or symmetric, you can calculate the mean. Whether it's skewed or symmetric, you can calculate the median. Okay, it's just that when you have symmetric data, we might prefer the mean and the standard deviation. When we have skewed data, we might prefer the median and these other numbers as well.
So there's more, more options with the skewed versus.
I wouldn't say options is the right word. I would
Just
say
like calculate, I mean,
I would say there's more things to do for skewed data.
in order to get the numeric data for this. Right? Wait, hold on. So you would calculate, so the way you would get numeric data for, okay, I'm answering that question.
Yeah. Don't fully understand your question. I'm really sorry. So if your data is symmetric, maybe another way to put this is that if you have symmetric data, it is probably enough to say the data is symmetric, the mean is this, the standard deviation is this, and that will give people a clear picture of what your data kind of looks like.